welcome you guys once again to my channel. Alright, so today we want to dive into a very specific subtopic under friction called a climb plane. Like you guys already know, my name is Humble Genius. Alright, make sure you subscribe, like and comment on the video for more interesting contents. Alright, so we are going to be solving 5 questions on inclined plane friction problem. Alright, 5 exam questions. These are even FUTO exam past questions. Alright, so this is very handy for year 1 students that are writing their exams tomorrow on physics. Alright, make sure you watch this video to the end. So now let's go. Look at, I have fished out some 5 past questions on inclined plane. Alright, so now we will go down to the analysis of what an inclined plane looks like. Okay, so here we go. So an inclined plane is something you have a bus, then a bus trying to slide down or up anyone. So let's assume this bus is trying to slide down. Okay, so it has its weight force acting downwards, then the normal reaction, which is acting upwards, vertically upwards. So you have it going down like this. Alright, so this is normal reaction R. Some textbooks calls it N. Alright, okay, so with what we have here, there's an angle formed here which is geometrically equal to the angle here also. Alright, okay, so this is a 90 degree, of course, and this is our weight, which is equal to mass times acceleration due to gravity. Alright, did you understand what I've done? Sure, I hope you understand. Of course you will understand. So we all have here, we remember our resolution of forces. A weight is a force, so it is inclined to an angle. Of course, it will have a horizontal component and a vertical component. Just picture it this way. This is our horizontal axis, this is our vertical axis, horizontal axis, right? And with this is our vertical axis, this is our horizontal axis. Are you seeing it? So this is the weight force. Alright, and this is the angle, this theta, inclined to the horizontal. But here it is not inclined to the horizontal. Of course, this is not inclined to the horizontal, it's inclined to the vertical. So this is our angle. So let's call this phi. Alright, let's call this phi. This is the angle of our interest. Angle of interest, alright, is inclined to the vertical. So when our angle is inclined to the vertical, our Fy, alright, Fy becomes what? F cos theta. Alright, so it means Wy is equal to what? W cos theta. Alright, and Wx is equal to what? W sin theta. So that makes the horizontal component of this weight becomes what? W sin theta, and the vertical component becomes what? W cos theta. Of course, you've seen now that this vertical axis is our normal reaction. So it shows that in an inclined plane, normal reaction R is equal to what? W cos theta. Hope this makes sense with us. Okay, and then we have W sin theta, which is the horizontal component of this weight. Now there's something I want us to understand about an inclined plane, and this is it. Now in an inclined plane, we find out that when we have, let's assume this is on this paper, and then I try to incline this paper. This is an ordinary plane, a horizontal plane. Let's assume I want to incline this paper. Okay, I want to incline it. This is my load on this paper. As I'm inclining it, I'm increasing the angle. You find out that this biro tries to fall without me adding or exerting any force on the biro. Now there is a natural force that is pulling that biro, which is the natural horizontal force, which is parallel to the plane, and that natural horizontal force is this W sin theta. So I make it move to this direction, natural horizontal force W sin theta, which is the same thing as mg sin theta. All right, so naturally this guy tends to move this guy down the plane, all right, without any force. All right, so since this guy naturally tends to put this guy down, there will be an opposite and equal force trying to pull it up or try to maintain it at this particular point, and that force, we call it the frictional force. Of course, you know frictional force always opposes motion of a body. So now let me start from case 1. Let's say case 1. Let's say the body just begins to slide or is about to slide down the plane. Now, with what I have here, since I said the body is just about to slide down the plane, okay, it means the body has not started motion. All right, at this point we say motion is impending, is about to take place. Motion is impending. The body is about to slide down the plane, so it is about to slide down. It means all the forces acting on this body now is equal to 0. Why? Now I'm going to tell you why. It means at this case where the body is just about to slide, there is no motion yet, so acceleration is equal to 0. Acceleration of this body is equal to 0. We can also term this case as when the body is moving with what? Constant speed, or when the body is moving with constant speed or constant velocity. All right, acceleration is always equal to 0. So in this case now, we say F net, summation of force, or summation of force along this x. Of course, this is x, which is still the same as summation of, which is F net, or let's just say summation of force. F net is equal to what? ma, and that's acceleration along the x-axis. Of course, I don't want to make use of all this, but let's just say F net is equal to what? Ma, mass times acceleration. Of course, you know naturally that force is mass times acceleration. All right, so since we've ascertained already that the acceleration will be equal to 0, so it's sure that A will be equal to 0. A times M becomes 0. So I have F net is equal to what? 0. All right, easy. F net is equal to 0 because acceleration is equal to 0 in this case, which is our case 1. All right, now what are the total force acting on this body? Now we already said this body is about to slide down. All right, that was our case. We say this body is about to slide down. For this body to be moving down, it means this force is bigger than this force. All right, it means this force has overcome this force. That's the truth. So I can say mg sine theta minus fr is equal to what? 0. And somebody will be like, okay, I'm doing the wrong thing. That okay, this is supposed to be in the positive y x-axis rather, and it's supposed to be in the negative x. Well, if we do that way, we are still going to get the same answer. So let's say mg sine theta is equal to fr. Okay, let's assume I'm using summation f of x equals to ma. So that will give me minus mg sine theta plus fr equals to 0, right? So if I take fr to the next side, or take this mg sine theta to the next side, I'm going to have fr equals to mg sine theta. Of course, you see this guy are still the same thing. Does that make sense to us? So it means when this body is about to move, alright, we have frictional force equal to mg sin theta. In other words, this frictional force is the force that is needed to maintain this body from moving down. Alright, okay, let's talk about our coefficients of static friction, coefficients of kinetic friction, which you all know that they are both equal to what? Frictional force over normal reaction. All right, we've already ascertained from here that our normal reaction in an inclined plane is always equal to what? Mg cos theta from our resolution. And okay, we've made it known that frictional force when the body is just about to move, of course when the body is just about to move, also note is the same thing with when the body is at rest. The same with when the body is at rest. Take notes. The same with when the body is at rest. Alright? Okay? Alright, so now R is equal to mg sin theta, and R is equal to mg cos theta. My mu x or mu k, anyone you want to use, will be equal to mg sin theta over mg cos theta. Alright, so mg cancels mg, of course, and then I'm left with sin theta over cos theta. And I say but sin theta over cos theta is equal to what? Tan theta. Of course, that's the trigonometric identity. You should know that already in your memory. You should commit that to memory. So it means mu x is equals to tan theta x. Alright, so this is our theta x. Now this is established. Alright, so but what's the difference between mu x and mu k? Okay, these two guys are called coefficients of friction. Now mu x is coefficient of static friction. All right, while mu k is called coefficient of kinetic or dynamic friction. All right, so what is coefficient of static friction and what is coefficient of dynamic friction? All right guys, we'll talk about this in our next video. We'll be able to differentiate coefficient of static friction and coefficient of dynamic friction. That is what we'll talk about in our next video. But that's, I've explained what the inclined plane is all about. I've been able to give us some formulas to work with. All right, okay, another thing I need to talk about is, now what if, now look at this, what if there is a force P pulling this body up? All right, a force P pulling this body up, and of course, since this force P is pulling this body, it shows that the normal natural horizontal force, which is mg sin theta, will be acting this way. Frictional force will be opposing the motion, it also be acting this way. All right, so here I can say that F summation of force, which is equal to F net, is equal to MA, right? So what's our F net? It's going to be P minus mg sin theta plus FR equals to what? MA. All right, so P will be equals to MA plus mg sine theta plus FR. Of course, you know that FR is equal to mu what? Can be mu K, since it's moving, this guy is moving it, or mu S, anyone you want to use, any mu you want to use, any coefficient of friction you want to use, depending on what the question is saying. Abi? Then we've established our R is equal to mu mg cos theta. Alright? So we can substitute P becomes equals to MA plus mg sine theta plus coefficient of friction mg cos theta. So this is our equation. Now let's just jump into question solving. All right, these 5 questions in our next video, we'll pick one, I'll solve one, possibly solve another one, and then give you guys the remaining one as an assignment. All right, so if you've gained value from this our video, please make sure you subscribe. Please subscribe to our channel, subscribe, share, like for more video. Also comment for any other videos you would love us to make, and I remain your humble genius, your favorite physics tutor, and anything more we'll give you guys even in our channel. So thank you very much. All right, see you.